Have you ever wondered how your favorite video games are created, or how complex software systems are designed and implemented? These might be the work of a powerful language called C++. C++ is a general-purpose programming language that has left its mark in numerous domains, from systems programming to game development, and even embedded systems. But let's rewind a bit. C++ was born in the early 1980s at Bell Labs, the brainchild of Bjarne Stroustrup. Stroustrup designed C++ as an extension of the C programming language, but with additional features that would make it more versatile and powerful. One of these features was Object-Oriented Programming, or OOP, which allows for the creation of modular and reusable code. Now you might be wondering, what's the big deal about C++? What makes it so special? Well, one of the key features that makes C++ stand out is its compatibility with C. This means that C code can be used in C++ programs, which is a big plus for programmers who are already familiar with C. But that's not all. C++ also introduced templates, which enable the creation of generic classes and functions. This means that you can write algorithms that work with different data types, making your code more flexible and efficient. Speaking of efficiency, C++ is also known for its superior performance. This makes it an ideal choice for systems programming, game development, and other performance-critical applications. And let's not forget about the Standard Template Library, or STL. This is a powerful library in C++ that provides generic classes and functions with templates. It includes containers like vectors and queues, algorithms for sorting and searching, and iterators. To top it off, C++ allows for low-level manipulation of data, which means you can get up close and personal with your data and even directly access memory. C++, being a highly efficient and flexible language, offers numerous features that make it stand out among other programming languages. So whether you're a seasoned developer looking to hone your skills, or a newbie eager to dive into the world of programming, C++ is definitely worth checking out. One of the key characteristics of C++ is its compatibility with C, which allows C code to be used in C++ programs. This compatibility extends the functionality of C, paving the way for more complex and versatile applications. One of the most significant features of C++ is its support for Object-Oriented Programming, or OOP for short. OOP is a programming paradigm that allows for the creation of classes and objects. This enables code to be modular and reusable, significantly improving efficiency and organization. The principles of OOP, such as inheritance, polymorphism, and encapsulation, are all supported by C++, making it a robust tool for complex programming. But the features of C++ don't stop there. C++ also introduces the concept of templates. Templates in C++ allow for the creation of generic classes and functions. In other words, they provide a way to write algorithms that can work with any data type. This ability to create generic code boosts code reusability and efficiency, saving precious time and resources. Building on the concept of templates, C++ features the Standard Template Library, or STL. The STL is a powerhouse of pre-written code providing a range of generic classes and functions. It includes containers like vectors and queues, algorithms for tasks like sorting and searching, and iterators for navigating these containers. The STL simplifies many common programming tasks, allowing developers to focus on the unique aspects of their projects. These features not only enhance the functionality of C++, but also make it highly efficient and versatile. Whether you're building a simple application or designing a complex system, understanding these key features of C++ will empower you to create robust, efficient, and dynamic solutions. C++ doesn't stop impressing us with its capabilities. The language also provides robust memory management features. The power to control memory allocation and deallocation is in the hands of the programmer. By using the new and delete operators, we can manually manage memory, enabling us to optimize our programs for better performance and efficient use of resources. Another fascinating feature of C++ is multiple inheritance. This feature allows a class to inherit properties and behaviors from more than one base class. While it's a bit of a controversial feature among some programmers due to potential complexity, it can also provide a lot of flexibility when used correctly. Next on the list is operator overloading. This feature lets us define custom behaviors for operators when they're used with user-defined types. This leads to more intuitive and readable code, as we can use familiar operators in ways that make sense for our custom data types. C++ also offers exception handling mechanisms. By using try, catch, and throw blocks, we can handle runtime errors gracefully. This improves the robustness of our code as we can anticipate and respond to potential problems during execution. Finally, C++ allows for low-level manipulation. Thanks to features like pointers, references, and direct memory access, we can work closely with the memory and hardware of our systems. This makes C++ a powerful tool for system programming, where direct control over hardware is often necessary. But remember, with great power comes great responsibility. These advanced features allow for sophisticated programming techniques, but they also require a deep understanding and careful handling to avoid pitfalls and bugs. This is part of the reason why C++ has a reputation for being a challenging language to master. However, the rewards for those who persevere are immense. With these features, C++ allows for the creation of complex and efficient software systems. It's no wonder that this language continues to be a top choice for systems programming, game development, and many other areas where performance and control are paramount. Apart from being feature-rich, C++ is also known for its efficiency and performance. It's a high-speed language that allows direct manipulation of hardware and memory, making it a favorite for system programming, game development, and other performance-critical applications. Now let's get our hands dirty and explore a simple program in C++. We'll use the classic Hello World as our maiden voyage into the world of C++ programming. This simple program is often the first one taught or learned in a new programming language, and C++ is no exception. Here's how it looks. Hash include less than IOStream greater than, int main open parentheses, close parentheses, open curly brace, std : coot less than quote hello world, quote less than std : endl semicolon, return 0 semicolon, close curly brace. So, what's happening here? Let's break it down. First, we include the IOStream library, which allows us to perform input and output operations. Hash include less than IOStream greater than is the syntax we use to include this library in our program. Next, we define our main function. The main function is the entry point of the program, where the execution begins. Inside the main function we have a line that prints hello world to the console. std : count is the C++ way of saying, hey, let's output something. The less than operator is used to send the string hello world to the output stream, which in this case is our console. The std : endl is a manipulator that inserts a new line. And finally, the return 0 statement signifies that our program has ended successfully. Running this program will print hello world to your console, a small yet satisfying victory for any budding programmer. C++ performance makes it the go-to language for systems programming, game development, and other performance-critical applications. It's a versatile and powerful language that has stood the test of time, continuing to be a valuable tool in a programmer's arsenal. Output. Over the years, C++ has evolved and adapted to the changing demands of the programming world. From its inception at Bell Labs in the early 80s, it has continuously improved, introducing new features and enhancements in each of its versions. The first official standard of the language, C++ 98, laid the foundation. It introduced the Standard Template Library, or STL, a powerful set of tools that greatly expanded the functionality and efficiency of C++. The next significant update came in 2011 with C++ 11, which was a game changer. It introduced a host of modern features like auto-keyword, range-based for loops, and smart pointers. It made the language more user-friendly, expressive, and safer to use. C++ 14 and C++ 17 followed, each bringing their own set of improvements. C++ 14 simplified many features introduced in C++ 11 and added unique features like binary literals and generic lambdas. C++ 17 further enriched the language with features like structured bindings and std, optional, and more. The most recent version, C++ 20, is arguably the most significant upgrade in the language's history. It brought concepts, ranges, coroutines, and many other powerful tools, making C++ more robust and expressive than ever before. Throughout all these versions, one thing remained constant: the emphasis on safety and expressiveness while maintaining the efficiency and low-level control that C++ is known for. It's this balance that has made C++, despite its complexity, a favorite among programmers across various domains. Whether it's systems programming, game development, or embedded systems, C++ has proven its mettle. It's not just about the power that C++ provides, but also the granular control it offers over system resources, including memory management. So, as we look back at the evolution of C++, we see a language that has continuously adapted, improving with each iteration while staying true to its core principles. Whether you're creating a game, building an operating system, or developing an embedded system, C++ provides the power and flexibility you need. So, why not give it a try?